Merker here at the corner of the screen, and we're just recording a screen live here in Microsoft Teams. We're celebrating, and I'm celebrating here with Tristen Pierson. Tristen, what has the mad scientist in Michigan discovered today?
Well, we've improved your tech. We've improved your tech with your what we candles, right? Candles.
Yeah, I called candles was this is just the name. I have the sheet right here. So
Perfect.
candles. This was the candles code. I called it candles because uh, it's sort of you think of it like kind of like Morse code or some kind of phonetic algorithm. It kind of began like K, N, D, L, and then S. So 1, 2, 3, 4, 7 in the language in the system, like candles is sort of when you get used to it, not right away.
I like the name, and why I like it is because
Yeah,
that term is an electrical term for lighting as well. So to me, it kind of has that double meaning. Not to mention there's that embodiment of it doesn't have to be
yeah.
just a color grid. Like I think I got my blur on. Let me turn my blur off.
Oh, you're
It
blurred.
doesn't have
Yeah.
to be a color grid. It could be lights. I know you have your
Oh, yeah.
or it could be multi-grid.
Uh, yeah. This was the pattern I've always been using. I'll grab my light board in a second. I was always using a 7 by 7 grid with two sort of blocks left out. So, in fact, you know, when you have 100 songs or 50 songs, you can line it up like this, and then they're kind of fractal like, let's say, but every square always has these two blacked out. So imagine there's 8 colors. The black is like the zero, the crossword puzzle blacking out, and then
Yeah.
there's 7 square colors. In real life, we have physical blocks to demonstrate it. So yeah, like this would be, yeah. Here I got these. I'm using white as the frame, and then we have the
Yep.
7 colors exactly. Yeah, but you always come back to the same. I was always using a 7 by 7 pattern. This board is particularly 8 by 8. Just charging it at the moment here. What else? What else in this
Yeah.
celebratory moment here?
So this is
Yeah.
the grid that I used today. So I modified our encoding, and I love that, by the way. That is awesome. I can see like the
Welcome
bolts
to
onto the yeah.
Galaga.
Exactly. I mean,
Beautiful.
I got all those '80s games in my head when I see that. You know, all the like
Amazing.
Pac-Man, the different variations and things like that. But this new grid that I have, built on top of your tech, it built on top of my tech, and it at the same time, due to the necessity of keeping good compression, we found a new approach of being able to save the number of bits required for doing the RS type error recovery.
And yeah, yeah, incredible. And I'm holding a 7 by 7 grid of pixel light. This was my version of Eye of the Tiger originally, and you have a different version of Eye of the Tiger. Your version, and what makes your version so cool?
What makes mine so cool is that it's a full URL. It's a link. It's not phonetic, where everything you've done so far has been 100% phonetic based, which is fantastic for compression because it's lossy. You know, with phonetics, it just has to sound right, and it's fine, which is perfect for lossy type compression. When you're dealing with web links and things that QR codes are used for, there's no tolerance for lossiness. It has to be losslessness. So it cannot be lossy, meaning that the checksum going into the compression has to match the checksum coming out of compression. If the checksum doesn't match, then something in your data was not recovered properly. It broke. So what this does is it fixes that. It makes sure that things are recovered to their original contents. And that is why you do see at the top of this a
Yeah.
section above the black section. So the
That's
black,
right.
those are nulls. They're nothing. They're separated. So the top section is your metadata that helps to define how to then extract and decode all the real data down here. These four colors on the corner, those colors are not actually data. They're actually there to identify the edges of this and to calibrate the color, to account for things like uneven lighting, orientation, and other things like that. So that way, no matter how it's oriented, the camera will be able to pick it up.
That's right.
This has data recovery, meaning that if colors start fading and things aren't perfect, it will have some ability not just to say, hey, there's a data problem, but it actually will recover certain issues. And what you're showing me right now directly applies. We could change the form factor. We could put it in a light tile like what you have there.
Yes.
That way this is viable to use in the dark. In fact, it might even detect better in the dark, since as long as the light tunnels are not overly dispersing into the next cell, as long as there's a nice clean gradient between the two of them, the concept works well. So it'd be interesting to see if we could apply the same concept here to that. But the reason why I chose single blocks and not doing the larger block sizes that you've done before is to prove that we can get good resolution on smaller tiles, smaller pieces. So I could scale this up, and it'll work just as well, if not better. I could take each one of these blocks and make them into 4 blocks instead of 1. So that way the ability to take pictures, even on a lower quality camera, will still work very well. And by the way, I'm doing this on one of my Logitech webcams, is how I'm detecting it. So I anticipate that detecting it on any modern smartphone, especially iPhones and Pixels, are going to work very well.
Brilliant.
Because they do have very good high-quality cameras that have a good ability to detect different colors and different varieties of colors.
Brilliant. And I see you got the blocks behind you there. You've become a Pixbricks. You got your 6,000 blocks.
Oh, yeah. And I'll probably get a couple more so I can get the full palette, because I would like to start playing around with different shades of colors and seeing how many can we get away with. Because right now we have 8 colors. Yeah. If we were to, I think they have triple the palette here. So if I were to add all the other colors and we can distinguish them from one another, that we can get that much more resolution out of this.
Yeah. I like how you were able to add the metadata, and I like how you set up the red, blue, green, yellow kind of corner colors. Is it 4 corner colors needed, or how does that work for the corner detection?
You do need 4. If you do 3, you get more errors and a harder time picking it up. So I would say that it's mandatory that you have 3, because that'll give you orientation. But having 4 will give you the best chance of getting past the different lighting differences and other obstructions that could impact your ability to do this. Even the amount of gloss on this can have an impact. The more dull, the more matte the material is, the easier it will be to detect. But these blocks are quite shiny. So if you have a lot of shine in your environment, it can impact your ability to get a good scan.
Yeah, I'm just showing off all my different favorite shapes, large, medium, and small. And do you think...
I like those colors. I feel like if we change the colors here, like blue, for instance, if this were a darker blue, we would have an easier time reading. And then maybe changing yellow to orange or something like that. Like, we might be able to redefine a better color set that works better for even lower quality cameras.
You're so right. You know what happened for me when I first discovered Pixbricks, which is the thing we're using here. So the Pixbricks, they have 3 different palettes. They kind of have black, white, and then 10 colors. So the different palettes always maintain black and white. I started with the dark palette, but then my daughter, she just turned 4 a few months ago. She always liked the lighter colors. So then I switched from, light blue, instead of dark blue, this is the dark blue, darker colors. She liked the lighter colors, like for the light pink and the light blue, and my son also. And then, it's funny, when you have little kids, tangent, when you have little kids, if they don't like food, they spit it out and they say yucky. If they don't like a toy, they throw it against the wall and run away. But what's really cool, I've been delighting in the color punching system. This here, although the colors are not perfect at the moment, like for example, it doesn't match the magic code. Where did I put that code? It doesn't match the it doesn't match like the color puncher here. It doesn't match the palette, and also it's not. I literally just removed the buttons on top of the numpad. But do you think it's easy to change the LCD light within a single unit of a numpad, of a color, I guess a color numpad? It's not hard to just go inside and remove one light behind the scenes so that the one is yellow, for example, instead of green. It's not hard to adapt to any other palette. But this puncher system and computer terminal, yeah, like a 4-year-old girl can use it. So that was the scan. Even a baby could do the scan. You just have to hold the object in front of the computer and it'll start playing. A baby could, crazy epiphany here, a baby could have baby blocks in a fixed pattern, not that they would eat them, but if they come ready built and they hold them up to I guess you could hold it up to a computer with a camera or a phone, and it will start playing a specific song. And there's no thought, there's no input. A person with severe physical disability, maybe this also services the non-standard computer input use. Me and you, we can always jump in, be like, Google search Eye of the Tiger, or search top songs from 1982, or Rocky 3, soundtrack. But to a person who's not using a computer in a traditional way, they can hold up a pattern, and boom, it starts playing. Hold up a different pattern, it starts playing. So it solves what do you think? It solves both the toy novelty plus little kids or people with physical handicaps,
I just
dexterity.
think about Parkinson's and things where you can't really use a keyboard, but maybe you can hold one of these, even if you're shaking up a little bit, with the right kind of camera that can capture with a higher frame rate. You ought to be able to get a good view on it, no matter what this is doing.
That's right.
Yeah.
That's right. And because there is the fun of building it by the blocks to create any song you want, and they're reusable. They're reusable. They're just color blocks. They're all the same size and shape. So it's reusable. Do you think this adds tremendous value to the block itself, to the block company selling the blocks?
I think it could. I'm not sure how much value. I'm sure they would know how to answer it much more than I can. But it just shows another utility, another use of their blocks. So from a STEM point of view, I think it opens up some big windows. For one, it allows you to build your own encoders and decoders. So maybe for some more advanced STEM courses, it could have some good value. I like the idea of, if I constraint type, CPSC ends up becoming a bigger thing in the future, this is a great way of teaching that as well, because it's something physical you can look at, you can build, you can think about it. It allows you to interact with it, so it's not just this abstract thing that you're programming in an FPGA or in an embedded C code. It's something you can physically see.
So a beginner, or not even a beginner, but when you have at a beginner level, learning about computer science or computer hardware or machine learning or anything where you need anything that's extremely abstract, this then in computer science, this allows it's kind of like a tactile, reduced focus on getting into both the user interface, the way data is packaged or stored, the way a phonetic algorithm works, the way it's sort of like a useful teaching aid, learning aid.
Yes.
For what else? What other ideas are brewing in your mind, Mr.
I just
Engineer?
think art in general. I think when you put these together, They're they're unique, especially when it's lyrics, because when it's lyrics, you notice patterns looking at it that pop out at you. When it's arbitrary data like this, it might be more difficult to see, but it's still art. It's still a pattern. Everything is derived from the English language and exposed as phonetics. So I just picture there being like, maybe a museum of music, or like, I know they have those museums like Museum of Illusions and stuff like that. Like, could you sell something like this to a place like that, where they have these tiles that they put up on the wall, and they allow you to open up your phone to an app so you can scan it and see what it actually is? I definitely think there could be a place for it at places like that, or maybe STEM museums that are more into the sciences than anything else. And some of these places, like the Museum of Illusions, they're in every major city in the United States, and I'm sure they are in Canada as well, and all of North America.
You're right. Something like, if you're looking at this and seeing a gray. Do you see a gray 2 from your angle, or?
Yeah.
Okay, so you see a gray 2.
Or an S, depending on which way it's turned.
So you see a gray 2, but me on this side sees a green 5. So there's one physical object, but from your perception, it's a gray 2.
Yep.
Or S. From my perception, it's a green 5. Yeah, I get it. There's some kind of cool. There's an immediate cool illusion element. You don't need to fall down the rabbit hole of being a computer engineer or study data science to delight in it. And I had another one. Where did I put it? I had like a S and a 7. I had this also. This is the this was the original. This was built by a 7-year-old.
that looks like it took a while to make.
What is it, like 4? These are 4x4 blocks, and then it's like each pixel unit's kind of like a 4x4. So 16 plus 16 plus 16 plus 16 plus 16, 3, 5, 6, 7, 8, 9, 10, 11. I guess somewhere like 200, or no, maybe like 170 blocks to make most of the numbers around there. Yeah. And
wow.
Then my whole basement is flooded. My whole basement. I came across this. This was a Connect 4 board. It's 7x6, but it's really cool when I can be like, okay, how would I measure this? Look through this to see a square. I don't know. There's funky. Most kids' toys. Many array of kids' toys. I have one right here. Even baby toys. They have some color number functionality, like yellow 1, open to see a blue monster. Red 2, push to see a monster. Green 3. There is a arbitrary nature across all the toys. Here we have a non-arbitrary. What did I call it? I call it you have to correct me here. Color by number phonetic cluster methodology. Color by number phonetic. Very good. Okay, I think this will hold over here. We'll close over here for this beautiful episode of Puzzle Time. Amazing. Okay.